So far in this unit, we have learned how to solve quadratic equations in two different ways. We have learned how to solve them by factoring, okay, and we've learned how to solve them by undoing the equation with square roots. Those are the two ways that we've been able to get x equals and x equals, because that's what solving means. However, there are going to be many problems where neither of these two methods work. We can't factor it, the equation's prime, and where we can't undo it, where we've got a third term and we can't get x by itself. So I'm going to show you a problem that is in this situation. So x squared plus 8x plus 2 is a problem that works this way. If I try and solve this by factoring, I would make the x, I'd put a 2 here and an 8 here. Now the only factors of 2 are 1 and 2, right? But there's no way I can get an 8 out of 1 and 2. So this doesn't work. Factoring doesn't work for this problem. Square roots, we've talked about this before, where if I have a problem like this with a third term, and I try and get x by itself, you're going to see that I can't take the square root of both sides because I've got this guy in the way. So neither of these methods work. Now I know there are solutions to this type of equation, because there's a solution to every quadratic equation. They may be fractions, right? Because when factoring, we don't ever use fractions with factoring. Or they could be those imaginary numbers we talked about, right? Where we take the square root of a negative number. We saw that in the last learning target. So there's this really cool formula that actually has been discovered thousands of years ago. This relationship in quadratic functions and how the a, b, and c relate to each other. So we're going to teach you this formula today. We call it the quadratic formula. And it uses, when we have a quadratic, it's always in this form, ax squared plus bx plus c. Okay, this is our normal quadratic function. And you know you've got these letters, the a, the b, and the c. All right, those are always numbers. Well, in the quadratic formula, we have all three of those letters. We have b, a, c, and a. So the way this formula works is you take all those numbers, you plug them into this large formula, and you do order of operations to get a solution. Okay. The really hard part about this formula is plugging them in correctly and keeping track of your signs. Okay, and we've seen so many mistakes with you guys in signs. It happens all the time, and a lot of it's because you aren't careful. You're just trying to rush through it. You're not showing your work, and that's where we run into problems. So I want you to pay really close attention to how I use this formula. Okay, I'm first going to show you factoring to show you that to make sure our solutions match. So factoring method, I'm going to put the 12 here and the 8 here. Okay, I know 6 and 2 work because 6 times 2 is 12, 6 plus 2 is 8. So when I go to put that in my Punnett square, I have x squared, 2x, 6x, and 8. Okay, I know this says r, but we're going to just make them x's to make it clear. So I know x and x here, 2 and 6 here. Oh, sorry, not 2 times 6. I had to look at that for a second. Sorry, it's 12 here. Okay, now that makes sense. So now I've got x plus 2 times x plus 6 equals 0. And then, of course, we learned that to pull these two things out and subtract on both sides. Wow, guys, I'm really struggling here. Sorry. Okay, minus 6 minus 6. So I get x equals negative 2. And I get x equals negative 6. Okay, so that's the factoring method. So if I use the quadratic formula, I should get answers of negative 2, negative 6 if I do it correctly. Okay, that's one way you can check your work, is you could try and factor it. So here's how this works. The first thing I'm going to do is I'm going to label a, b, and c. So a in this equation is going to be that invisible 1. A is 1. B, I'm going to use different colors to show you. B is going to be 8, and then C is going to be 12. Okay, that's this right here. A, B, and C. I would always label these so you have them for reference. Now we're going to take them and plug them in. So I like to do my skeleton first. So here's my skeleton. I have a negative sign from the formula, right? And then whatever I plug in for B, I'm going to use parentheses. Plus and minus, remember we've seen that symbol before because sometimes we have a positive solution, a negative solution. Square root I'm going to put parentheses and then squared, because I'm going to plug something in for b, minus 4, and then 2 sets of parentheses for a and c. So do you see how I took every variable in the formula and put a parentheses? Okay, if you don't do this and you ask me for help, I'm not going to help you. Okay, if you do not have your parentheses, I'm not going to help you because you're legitimately giving yourself a high chance to make a sign error, and I need to see the skeleton. Okay, we got to finish the skeleton by putting all of this over 2 times a. So that's 2 times of parentheses. Now we're going to take our numbers and plug them in. So I know a is 1. A goes here and here in my formula. So see, I have a there and there. I put a in those 2 spaces. Now I'm going to take b and put b in these. There's a b here and a b here. So I'm going to put 8 here and I'm going to put 8 here. And then the last letter that I use is C, and C is that one on the very end, and C is 12. Okay, the last thing I want to make sure that you do is see this x equals right here. Put that at the front of your equation. Okay, now we're going to simplify. Now I'm going to simplify this. I'm going to get rid of the set of parentheses. That just becomes -8. The parentheses go away. I'm going to leave my square root symbol. 8 squared is 64. So I'm going to turn that 8 squared into 64. So I've taken care of these 2 things. Now I'm going to multiply -4 times 1 times 12, because that 4 is negative. Okay. So -4 times 1 times 12 gives me -48. So now I'm going to cross off this and put -48 here. Over 2 times 1 is 2. It helps to cross things off because then you know what you've simplified and what you haven't. The next thing I'm going to simplify is the square root. So I'm going to put x equals -8 plus or minus the square root of 64 minus 48. 64 minus 48 is 16, which is nice. That works out to a perfect square. Then I get x squared equals -8 plus or minus, and then the square root of 16 is 4 over 2. Now here's where things get interesting, because now I've got 2 different answers, and this is weird. I've got the positive version, so I'm going to have x equals -8 plus 4 over 2, and I'm going to have a negative version, right, because I've got the minus sign, so I'm going to have an x equals -8 minus 4 over 2. So now I've got to solve each of these now. So when I solve these, I have -8 plus 4 gives me -4 over 2, which gives me -2, which is awesome because that's one of the solutions I got on the right when I factored. The blue, I've got -8 minus 4, which is -12 over 2, which gives me -6. Also awesome because it matches my factoring. So if you do this correctly, you will get the right solution. Okay, the hard part is just the plugging in, the simplifying, and doing all these steps. Do you notice how in my work it's forming like a upside down triangle? Guys, I can't express to you enough the skill of showing your work. And so many of you do your work all over the page. You don't follow through. This is the place in Algebra 2, as we're getting, this is an Algebra 2 topic almost, where you've got to start organizing your work, okay? We're going to do 5 more examples of this, okay, because each one shows something a little bit different in our answer, okay? So bear with me with these 5 examples. So I've got 2m squared minus 4m minus 48. I'm going to use the quadratic formula with this. I know normally when we saw this we could multiply 48 by 2 and factor, but we can also solve this with the quadratic formula, okay? So I'm going to go ahead and label A, B, and C. Okay, A is going to be 2. In fact, I can use different colors here as well. A is 2. B is -4, watch your signs, and C is equal to -48. Now I'm going to make my skeleton. So I've got negative skeleton B plus or minus the square root of B squared minus 4A times C all over 2 times A. So there's my skeleton, X equals. I'm going to plug everything in. So I've got a 2 here and a 2 here. That's where the A goes. I've got a b that goes here and a b that goes here. And then finally that negative 48 is going to go right here. Okay? Now I'm just going to start simplifying. X equals, be careful here, I've got a negative and a negative, which gives me a positive 4. Plus or minus the square root of negative 4 squared is 16. Negative 4 times 2 times negative 48. Watch your negatives. A negative times a negative is a positive. So when I put that into my calculator, negative, let me turn this on, negative 4 times 2 times negative 48 gives me that positive 384. So I'm going to have plus 384 all over 4. Boom, boom, done. Now carry down the 4. 16 plus 384 gives me 400 over 4. And the square root of 400 is actually a perfect square. The square root of 400 is actually 20. So I'm going to have 4 plus or minus 20 all over 4. And then here's the part where you break it into two pieces. Okay, I'm going to take the positive piece, x equals 4 plus 20 over 4, and I'm going to take the negative piece, 4 minus 20 over 4. Okay, so the first solution, I'm going to have 24 over 4, which is going to give me 6. And the other solution I'm going to have is going to give me x equals negative 16 over 4, which gives me a negative 4. Okay? Again, notice how my work formed this little upside down triangle. Okay? The next problem is a little weird. This one on the right here. It's a little strange because I don't have it equal to 0 first. And this is really important. You've got to get it equal to 0. So I'm going to go ahead and subtract v over on both sides. I get 6v squared minus 26 and then minus v equals 0. Okay? Now I'm going to label my a, b, and my c. A equals 6. B equals negative, Now here's a really good point. I'm stopping myself right here because I did something interesting. See how I didn't put it in standard form? I put the 26 first. So what I'm going to do is I'm going to rearrange this, and I should have done it the first time. This should be 6v squared minus v minus 2b. Right? Now my v is in the right place, and now I know my b is actually negative 1. If you don't put it in the right order, then you're going to have your a's and your b's and your c's mixed up, like I would have almost done. Okay? And then the last number is negative 2. So c equals negative 2. Now we're going to plug everything in. To save some time, I've already plugged in my skeleton, so I'm just going to plug in my letters. A is 6, so I'm going to put the 6 here. And I'm going to put a 6 here. And then B is negative 1, so I'm going to put a negative 1 here and a negative 1 here. And C is negative 2. Now I'm going to go ahead and start simplifying. Negative and negative 1 give me a positive 1. Plus or minus the square root of negative 1 squared is 1. Minus 4 times 6 times negative 2. Let's see, negative 4 times 6 times times negative 2. It's going to give me a positive 48. So I'm going to have 1 plus 48. Takes care of that, all over 12, because 2 times 6 is 12. Keep going, x equals 1 plus or minus the square root of 49 over 12. And now I'm going to get two different solutions, right? I'm going to split it up here to save some time. So the first solution is going to be x equals 1 plus 7, because square root of 49 is 7 over 12. So x is going to give me 8 over 12, which gives me 1/4. And the other solution is going to be 1 minus 7 over 12, which gives me negative 6 over 12, which gives me negative 1/2. So it's okay if you get fractions. That's totally normal and okay. So, you know, when you start doing this, please expect to get fractions for some of your answers. Okay? All right, this next problem, I'm going to start it off for you, and then I want you to try and do it on your own. The only tricky part with this one is getting it equal to 0. So I'll start you off with that, and then I want you to kind of go on your own here. So I'm going to go ahead and add this 4k squared over to both sides. I get 6k squared minus 7k minus 36 equals negative k. I'm going to add that k over. I get 6k squared, and then 7 plus 1, negative 7 plus 1 is negative 6k, and that equals 0. Okay, so there's my form. I'll go ahead and label A, B, and C for you. A is 6, it's right here. B is negative 6 here, and C is negative 3. Now I want you to go ahead and try and write your skeleton, plug it in, and see if you can get 2 solutions. Okay, so pause now and try this one on your own. You will get whole numbers, okay, just to give you a heads up. You should get x equals negative 2 and x equals, positive 3. You should get a positive 3 and a negative 2, okay? If you didn't get these, please come talk to me like you should. You know, we want to make sure that you're correcting mistakes as you go. The last 2 problems have really unique answers. They're not fractions and they're not whole numbers. So I really want you to focus on these last 2 because they're going to look really strange. So just like the other one, we're first going to have to get this alone. So I'm going to add the 9 and subtract the k squared. And I'm going to do this in one step. I often do this to kind of help save myself some room. So these both cancel out to 0. 8k squared minus k squared is 2k squared. Bring down the positive 8k, and negative 21 plus 9 is going to give me a negative 12. Okay? So now I'm going to go ahead and label A, B, and C. A is 2. B is 8. And C is negative 12. I'm going to make my skeleton. I have negative x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So there's my skeleton. I'm going to go ahead and plug my numbers in. A is 2, so a 2 goes here and here. B is 8, so 8 goes here and here. And C is negative 12. Alright, now I'm going to go ahead and start simplifying. Alright, I get x equals negative 8 plus or minus the square root of 64. Negative 4 times 2 times negative 12 is going to give me a positive 96 all over 4. When I reduce this, I'm going to get the square root of 160 over 4. Now here's the problem. When I go to my calculator and I'm going to type in the square root of 160, because I don't know if that's a perfect square at the top of my head. I mean, I do, but I doubt you guys have those memorized. So the square root of 160, when I put that in my calculator, I get this decimal. Now this is where that last learning target came in, where we had to reduce the radical. So unfortunately, you're going to have to reduce that. So we're going to go ahead and what I like to do is I like to take, I like to bring out the radical somewhere else and reduce it somewhere else to save myself some organization. So the square root of 160 breaks up into the square root of 16 times the square root of 10. Okay, we learned this before. You break it up, find a perfect square. That perfect square of 16 is 4, so I end up getting this 4 square root of 10 for 160. Once I know that this is my simplification, when I go ahead and reduce, I'm going to get x equals negative 8 plus or minus, and I'm going to go ahead and plug in 4 square root of 10 into this quadratic formula. Okay? Now I'm going to get those two separate answers. Now I'm going to bring this out. X equals negative 8 plus 4 square root of 10 over 4. And x equals negative 8 minus 4 square root 10 over 4. Now if you left these answers like this, I would take it. I might give bonus points if you actually go one step further. And the step further is to butterfly this and to reduce these two fractions. So I'm not going to force you to do that, but if we butterfly this, I get x equals negative 2, because negative 8 divided by 4 is negative 2, plus 1 square root 10. Then if I do this one, I get negative 8 divided by 4 is negative 2, and then negative 4 divided by 4 is minus 1 square root 10. So I get these two answers. These are the best answers by butterflying and simplifying, but if you don't do that and that's too hard, then I will take the above answer for sure. Okay? Alright, we've got one last problem that we have to talk about. Alright, last one, and this is the weirdest answer you're going to get. I'm going to go ahead and start solving this, the first step here. Minus 10x squared on both sides. You're going to get 12x squared plus 12x plus 22 equals 0. Alright, now like normal, go ahead and label your A, B, and C. A is 12, B is 12, C is 22. Okay? So we've got negative B plus or minus the square root of B squared minus 4 times A times C over 2A. I'm saying this over and over in hopes you guys memorize it. I doubt you will, but it makes this much easier if you memorize. I'm going to go ahead and plug my values in. So I've got negative 12 plus or minus the square root of 12 squared minus 4 times 12 times 22 all over 2 times 12. Okay? This reduces to negative 12 plus or minus the square root of 144. That's what 12 squared is. And then minus, let's put that in a calculator, 4 times 12 times 22, negative 1056 all over 24. Now, before I go any further, I want to notice something here. Well, actually, we'll notice it here. When I go ahead and do 144 minus 1056, sorry, let's go back to the calculator. So here's what I'm looking at. I'm looking at this 144 minus 1056. So 144 minus 1056 gives me negative 912. And this should ring a little alarm bell in your mind. When you get to this point and you see this thing, oops, let me get a different color. When you see this minus sign under a radical, you can stop working right here because there's a really, that you can't keep going. We cannot take the square root of a negative ever. And we learned in the last learning target that this answer to this is no real solutions. So you can stop here and write that, no real solutions. And you'll even know if you go to your calculator and you put in the second square root of negative 912, you're going to get an answer that says non-real answer, okay? Because you can't hit the square root of a negative. So that's one way to check to see if that is the right answer, is that your calculator will tell you that it won't work, okay? So this is the quadratic formula. It is a lot of steps. I don't know if I've given you enough room on your paper. I've tried to. I've only given you 12 problems to do on your practice. If I haven't given you enough paper, please use a separate sheet and staple it. I do need to see every single step. And you can see how I write tiny and it's still this big, so I need to see that really carefully, guys. That's it for this learning target. Good luck on your practice.